technical issues, or if you get knocked out and have to come back in, you lose your microphone, the things that tech department said was going on. So this is what I said. I'm just going to go ahead and go through this, and at the end of the lesson, if there's any questions, go for it. When I finish, then, it'll be your time to do whatever. We'll talk about that at the end. Okay, so you can see it's a real basic, simple equation solver. And if I was in class, I'd say this out loud. Hey, whatever I do to one side, then the class would say, we do to the other. So what we want to do is get balance in this equation. We can do it because we have an equation here, so we can use that rule. Whatever I do to one side, as long as you do it to the other, there's still balance in this equation. I really hope that you're fast like this. Like, let's understand that I want the x's on the left, and that means I want the 6 over on the right by subtracting. Cancel, cancel. All right, and then you get negative 18. Oh, no, a fraction. We hate fractions. Please get used to not just type it on your calculator. What's that decimal? Understand that 6 goes into both of these numbers. 6 goes into 18 3 times. 6 goes into 12 twice. So negative 3 halves. Okay, so there we go. We got a real basic start. Now I do have this online here. Again, we talked about management decisions. We're not going to be able to do all the notes that we originally have. We understand we don't want you staring at screens and me doing 1-hour notes. It's not going to happen, and I would never want to do that to you. But the other thing is we're going to do this in Chapter 2. So there's some redundancies in this book, and we're going to hold off on those, and hopefully you really focus in Chapter 2 when we solve fractional equations. So that's why that's kind of knocked out again. Feel free if you want to see, when you see a whole set of notes and the things that we skipped, if you want to come in at 2 to 3 and ask about those more complicated questions, that's perfectly great. All right, then of course we know when we see parentheses and we have to solve, we have to distribute. Here is the biggest mistake though ever made. Not making this plus a negative and then distributing the negative. This is one of the top dog, number one mistakes people make all year long. And then what that leads to is all year long of wrong answers when most of your math is okay, but then you make that one silly mistake that crushes everything. So please make sure we're all right with that. Always make minuses plus negatives, then distribute the negative. This is a whole lot of mess. So what I want to do is first combine like terms. Some students get crazy about trying to do whatever you do to one side, you do to the other. These are all on the same side of the equal sign. I kind of like to make a line on that equal sign. Since these are on the same line, you just go ahead or same side of that line, you go ahead and add those. 96, 06, 16, I think that's 120. Feel free to chime in with your microphone if I make a mathematical error. Got a lot on my mind here. And I like to do a lot of mental math. Sometimes there's a mistake, here and there. Now, I see if I move this negative 4x over here, then I will have a positive x when I'm done. So I'm seeing the future here. The future looks bright. So that cancels over here. Then what I'll have is x equals. Now I'll just have to read right to left. That being the case, I'm going to add 6 to both sides. So see, even I, mathematics man here, been doing this for 25 years. I still, just to make sure I'm balanced, because it doesn't take too much time, I still do whatever I do to one side, I do to the other. Those that skip steps and don't write those things tend to make big mistakes. Okay? All right, and then tell me if I'm going too fast. We do have this. Oh yeah, you actually have a note. I keep forgetting I gave you a note sheet. So you can open that up and you can write this pretty fast. Okay, moving right along. Before I do this one, I would ask in class, and actually I had a great calculator button where I'd give you guys numbers and I'd randomly select if people are paying attention or not. But we kind of lose that with this internet stuff. So, hopefully you're really focusing on your end here. But I know this has nothing to do with this question right now, and you don't need to write it down, but just got to ask what numbers work that make the absolute value of x equal 4 true, And what everyone should understand is it's 4 or negative 4. Really, the definition of absolute value is it is the distance a number is away from 0. So this is really asking what number or numbers are 4 spaces away from 0 on the number line. And the answer is 4 spaces away and negative 4. That's really what an absolute value means. All right? With that being the case anyway, I think you know the plus minus thing. So what you have to do with this one is you have two cases. X plus 8 is equal to 5, and x plus 8 is equal to negative 5. All right? Because 5 and negative 5 are 5 spaces away from 0. So you have to set up those two cases. And then you go ahead and solve. X equals, subtract 8, and you get negative 3. X equals, subtract 8, and you get negative 13. Then when you plug this in, how does this work? When I plug in negative 13, I get negative 13 plus 8, which is negative 5, but the absolute value of negative 5 is 5. So 5 equals 5, it works. Plug in negative 3, you get 5. Of course, the absolute value of 5 is also 5. All right, so that's why these are the two cases that work. So you can see I'm moving along, going pretty fast here. Again, anyone? Take a pause for a second. Hey, Logan.
Yeah.
Everything presenting okay here?
Yeah. Everything's
Okay.
going all right.
All right, so you can see my screen. We're on number 6 now, correct?
Mm-hmm.
Oh, I just used your first name, and you're going to be on YouTube. Are you okay with that?
It doesn't matter.
Okay, I could cut it out if you want. All right. Okay, here we go. Hey, whatever you do to one side, say it. You do it to the other, Mr.
Do it to the other.
Okay, thank you. Is that Logan? Nice. All right. Okay, here we go. So, how do I get rid of a square root? Well, you square it. A square root squared is freedom. Oh, as they get older, the kids don't know great movies like Bravehearts. Freedom. Okay, anyway. So that's really all that happens. You square a square root and it frees it, and then you're able to just go ahead and continue now that it's free. Oh, heck no, and you cannot add 5 before that. This is stuck in jail right now. So you can't be adding 5 now, but after you square, now it's free to be added. Hey, and I'll give you a little funky division rule. 1 plus 0 plus 5 equals 6. Since 3 goes into 6, 3 goes into 105. That's a funky little 3 and 9 rule. If you add the digits and the sum of the digits is divisible by 3 or 9, then the number itself is divisible by 3 or 9. Hey, put that in your little, maybe at the dinner table tonight with your parents or guardians, share that little nugget of information. Or not. Okay, 105 divided by 3. And I never was good at math. So 35? I think it's 35. Yep, I'm good. Okay, then if you were to plug, excuse me, if I were to plug in 35, 3 times 35 is that 105. 105 minus 5 is a hundo. Square root of a hundo is 10. So it does check out. Check, baby, 1, 2, 3. Okay, we're going to skip this one because this is both, we're going to solve these graphically. And notice that these are these are the exact same question. It's not that they cannot be done algebraically, but sometimes you do want to go to the graphing calculator and give it a whirl solving that way. So go ahead and grab your graphing calculator. If you don't have time to go get it and run and I'm going too fast, then just go to the video that I'm going to make on this and, look at this parts. I love this, actually. The first way that we skipped, we wanted to just do one thing, and it says subtract 5x, add 3, and then go to your graphing calculator and compare it to 0, which is the x-axis. This is a more direct and faster way. I like direct and fast. That's what a mathematician actually I think also teaches is efficiency, being efficient in what you're doing. Okay, but we do have a problem. How do I find the absolute value? And it's under math. And you're really supposed to have a TI-84, 83 plus, the 83, 84 family. So when you hit the math button right there, go 1 over to num, and there's the ABS. That does stand for absolute value. Press enter. If you have an older version of a calculator, it's fine. It just says ABS with parentheses. And then the X button is right here, plus 8. Then you stop and go to Y2. And then 5x minus 3. By the way, 5x minus 3, if you were to graph that, is a line. That's what our ed puzzle is on today. Okay, now this is why this works. And I would say this in class, and I would ask you guys to respond, but no one's, can do that with the computer here. But input. The other thing is output. Input is X, output is Y. And I'm going to use that terminology when I look at this graph. Ooh, and I have a fancy graphing calculator that the first one's in blue and the second one is in red. Oh no. Okay, I'm going to have to change my zoom because I'm trying to find where these intersect. So I'm glad this happened right away. So what I have to do is extend the y-axis higher. So it looks like it's going to intersect like right around here. So I need to move this up so I can see it. So I'm going to go to my window and extend my y maximum. I'm going to go to like 20 just to make sure we hit it, just to get it there. So you have to know how to do this stuff, and hopefully you are. That isn't a big deal. Takes a second. Boom, shakalaka. So here's what I was saying. The x-axis is here. When I input, it looks like right around 3, I get the same y output for these two graphs. That's why I want the intersection. What that will mean then is when I plug in a particular x, both of these sides will have the same number, which is what solving is. Let's go back up here. Didn't I check these answers? Didn't I plug in negative 13 plus 8, got negative 5, but then the absolute value of negative 5 was 5. 5 equals 5. Input, say it. Output. I checked 105. I'm sorry, wrong. I checked, what did we end up here? I can't slide over. Oh, come on. I made a mistake. Why does this have to be on the video? Okay, 35. I did the same thing with that. Okay, so when I'm looking at the calculator, I want to find this intersection. And then I'll do that again, talk about input, output. Second, trace, which is the calculate feature. So second, trace, which gives me this. And I want to find 5, the intersection. Here's what's great about this. You have to do nothing. You could go over to where they're close to intersecting. It says first curve, and notice it's going along the blue. But really, you could just press enter. Second curve, just press enter. I don't understand why they have this guess thing. Just press enter one more time. You need to hit 3 enters until you see intersection. So what this means for both the blue and the red, when I plug in 2.5, well, it's easy. When I plug in 2.5, I get 10.5. The absolute value of 10.5. And then or 10.75, wrong. I made a mistake there. I saw it's 2.75, not 2.5. And then when I plug in 2.75 here, I will get 10.75. But what I want is the input number. It is the x. It is the x that solves this. So x equals 2.75. That's a brain mishap again. Because when I plug it in here and I plug it in here, the equation is balanced and we have equal numbers. Okay, so that's what you need to understand there. All right, feel free to stop me as I go through the next one. And then hopefully in this you could really see what's going on here. Square root of, okay, so where's the square root function? Clear. It's under math again. Just have to find it. There it is. Actually, these have x roots. If you ever need a third root, fourth root, fifth root, that's what the x root button is there. So actually, where I'm going to go is second square root right there. It's above the x squared. And then what was it? I'm just going to move this. 3x minus 5. So same idea. 3x minus 5. And then move down. And then 10x squared. By the way, 10x squared is a parabola. Hopefully you know these things as we move along. Now, I may have to adjust my window again. We'll see. Square root function does look like that. We'll have a thing about, what the basic functions look like. Oh, no. Okay, so what does it look like doesn't happen with these two graphs? What does not happen? And the answer to that is they do not intersect. So what that means is there's no solution between these two. There is no number for x I can plug in for both of these that we get a common output value. They have no shared y's because they have no intersection. So what that means is this is a sad no solution. So if they don't intersect, there is no solution. And I know nothing else is happening with this graph because this is a parabola, because I know x squareds are parabolas, and square root functions do look like this. They have a starting point and then they just kind of rise forever this way. So that one was pretty easy. All right, any questions so far? Okay, then last but not least, solving some inequalities. I'm not going to do the first one graphically because it's just a linear one. But this next one, and then I'm throwing this out because this is in chapter 2 as well, number 13, but I'm going to do another absolute value one that has a little bit more to it. But I won't do the first one graphically because all this is a linear situation. When you have fractions, feel free to multiply both sides by the least common denominator. Logan, we still doing okay? Still see me?
Yeah.
You sure you're okay? You sound stressed. You all right?
Yeah. Will you have a key for these notes
Sure thing
later?
there. Yep, you got
Yeah,
it.
because you didn't put any for the last.
Okay, I'll get it up there. Got it. I'll work on that maybe when we're done here, which should be in probably about 5 minutes, maybe 10. Okay, but multiply both sides by 3. Okay, so that cancels that 3. Hopefully you're good a little bit fractionally to make your lives easier. I love fractions, but sometimes it's good to get rid of them. So whatever you do to one side again, do to the other. Nothing happens with this inequality. Subtract 5. And then when you divide by a positive, nothing flips. But if I divide by a negative, wrong. It's another brain mishap. When you divide by a negative, this inequality flip. I did not divide by a negative. I divided both sides by a positive. So no flippage of this inequality. Again, these are things that we are kind of supposed to know. I don't want to cover this one graphically, but what I want you to understand is on a number line, what this answer is -1 is here. And, we used to do open circles back in grade school. That says x is not equal to -1, but it's all the numbers after -1. So it's actually an infinite amount of numbers that represent the solution of this inequality. And that's what we need to kind of understand for that. So, that is the answer, right? And what are we supposed to say? The solutions. Okay, so this is called, get this down. This is called, you may not have actually done this because this is not the way we wanted answers in math 2 and 3, I think. This is called set builder. These are trizap braces, the old brace thing. This is called set, I can zoom in on this, set builder notation. And I think you should know that because sometimes a book will, have that in that notation. This is try to brace. What you did, and if not, those teachers back in the day, they were naughty because they were supposed to show you interval notation. And in interval notation, remember that this coincides with a parenthesis. If it was a filled in dot, meaning it was x equals -1 and is greater than, then that would be a bracket. This is a parenthesis not including -1, all the way through to the number that goes forever to the right, positive infinity. So this is what the CAT answer has to be, and this is something that should have been taught to you in Math 2 and Math 3. This says the exact same thing as this. All right, x greater than -1. -1 not included, all the way to infinity. And that's the answer that we need to be used to, okay? All right, now we got an issue with absolute values. I just told you with absolute value equations, going back up here, so value equations, there are two possibilities because the distance a number is from 0. 5 and -5 are both 5 spaces away from 0, and that's what you have to set up here. Okay, but then pay attention to these directions because I'm actually going to do that with this one. And then when we get to chapter 2 and do inequalities again, it's going to be the same process here. We ignore the inequality and write it as an equation first. Then we're going to find the critical points and put them on an x-axis number line. And then we're going to test which ones are the correct ones through plug and chug. So please pay attention to that. Before we do that, though, we got to get rid of this nasty 2. We want this absolute value isolated. So quite simply, to get rid of that 2 is to divide it. This is Mathematics 101, basic equation solving. Now that I have my absolute value isolated, then what we do is drop the absolute value, set up 2 equations for what numbers are 7 spaces away from 0. These 2 are. This is an inequality, though, and I'll show you how this works. It's actually very simple. It actually should be, we should start analyzing it right now. The absolute value of what numbers are smaller than or equal to 7, and we could start listing them. Well, -7 works and 7 works. Isn't -6, the absolute value of -6, less than 7 because it turns into 6, and 6 is still less than 7, and so is 6, and -5, and 5, and so on and so on and so forth. All the numbers in between -7 and 7 work for this absolute value inequality. Sometimes it's just smart to think about this in those terms. So what you do is you put -7 and 7 here. Since it's an equal to, I'm going to do the old school fill in the dots because they are part of the solution set. And then you check a number in the middle, out here, and do like a false, true, false check. So we already established what the right answers are. When I plug in 0, the absolute value of 0 is 0. 0 is less than 7. True. What that means is then any of these numbers that I check in between -7 and 7 will be true, just like I did real fast over here. And then when I plug in 8, well, that's going to be a false because the absolute value of 8 is 8, and 8 is not less than 7. So I don't shade there, and I don't shade there. So when it gets a little bit more complicated, you're going to want to do this false, true, false check. With that being said, it is kind of complicated in set builder notation. How that works for set builder is x such that the only way to do between is to say -7 is less than or equal to x, which is also less than or equal to 7. X is greater than -7 and equal to it, and also at the same time less than +7. For interval notation, colored in dots are brackets. And you just write it -7 to 7 bracket. And that's the CAT answer. I'm just doing this in case you run into this in the future. We should be aware of an older school notation for that. Okay, so one more, let's do this. Let's say it's like absolute value of 3x minus 4. And let's say greater than or equal to, let's just say 8. We'll probably get some fractions here. It's not a big deal. Okay, so here's how you attack this. There's an infinite amount of answers to this. We got to assess what they are. You first set up your 2 cases. 8 spaces away from 0 is 8 and -8. Now again, you do an equation just because we're going to analyze on a number line the inequality at the end. We're going to analyze it by looking at the original and plugging and chugging. So add 4, oh, that's nice. Add 4, that's 12. And then divide by 3, you get x equals 4. Add 4, no. 3x is equal to -4, and you get x equals -4/3. Okay, this is the part that students miss. Don't forget that this is an inequality. And don't forget that you need to put this in order of the number line. -4/3 is smaller than +4. So that's where they are on a number line. And then you start checking, and you pick numbers and you plug them in. So -4/3 is -1 1/3. We should at least know that from our grade school days. So one check that I should, oh, and by the way, I did an equal sign, so these are colored in dots. They are included in the solution set. Doing some old school grade school stuff. Hopefully they did do open and closed dots when you had equations or not equations. So what I want to check is -2. -2 is left of -1/3. This is all you got to do. 3 times -2 is -6. -6 minus 4 is -10. Is the absolute value of -10 greater than 8? True or false? And I'd say that in class, and the class would say, is that true or false, Logan? Is the absolute value of -10 greater than 8? True or false?
I'd say true.
Absolutely. So that means, Logan and everyone else, any number that I would have picked to the left, -3, -4, -5, any of those numbers I would have picked would have made that inequality true. That's what solving equations and inequalities are. What numbers makes this inequality true? I guarantee you're going to get a false on this one. 3 times 0 is 0. 0 minus 4 is -4. Of course, the absolute value of -4 is 4, which is not greater than 8. That's a false. That means you don't shade there. And you're probably going to get a true here because usually these do alternate between true, false, true. 3 times 5 is 15. 15 minus 4 is 11. The absolute value of 11 is still 11, which is greater than 8. True. Boom shakalaka. Let's just do the interval notation. The interval notation, just go in order. What number is way off to the left forever? And the answer to that is -infinity to -4/3. Closed dot means bracket. And then you put a union there, and I hope you remember this. Hope your math 2 and 3 teachers taught you this. 4 to infinity. So you mirror the graph. The graph is mirrored by interval notation showing, those same answers there. So we'll just do the interval notation on that because that's ultimately what you're responsible for. Okay, I'm going to shut down the movie. I am certainly here for the last